So this is a simple sum-simple problem. First step to do is you have to determine alpha, omega naught, fundamental frequency, and the time delay, and the phase shape. So first thing you do looking from the graph is basically you have to figure out the amplitude, which is the highest peak. So anywhere from here to here, this will be your A, which in this case is 2. And then starting from, and that's your A right here, so that's check. And to figure out the period, or T, is basically how long it takes to do one complete revolution. So like from here to here is 2 seconds, right? 2 seconds. But remember, this is in the milliseconds, so it's going to be 0.002 seconds. And then to figure out the time delay, or your TD, is going to be from the 0 axis to TD. This is 0.5, or 0.5 times 10 to the negative third, which is equal to 0.0005 seconds. So those are the simple things you can figure out just by looking at the graph. Not to figure out like omega naught, you have to do 2 pi times the frequency, and your frequency is 1 over t. And it's 1 over 0.002, which gets you 500 hertz. And then to figure out omega naught, just plug the frequency back in, so 2 pi times f times 500 will get you 1,000 pi radians per second. And then to figure out the phase, you do negative omega TD, which is negative 500 hertz times 0.0005, which gets you positive scratch that 1,000 gets you 0.5 radians. And that is how you do a simple equation like this. Alright, so now we're doing simple rectangular to polar conversion and vice versa. So for part A, when you have negative 33, j negative 33 squared, and you're trying to get into the x plus jy form is equal to z, you need these formulas. So you know the magnitude is the square root of x squared plus y squared. And you know theta is going to be the inverse tan of y over x. And so to start this problem, you do a unit circle and you try to find the location of your x and y coordinates. So in this case, it would be in the third quadrant over here somewhere. And so after that, you basically just do the conversion. So your magnitude is going to be, the magnitude of r is going to be square root of negative 33 squared plus negative 33 squared, which gives you 33 root 2. Because when you have here, it's 150 degrees. Using the unit circle, you figure out that it's going to be here, and then you get formulas like root 2 over 2, and then root 2 over 2. They're all negative, so this is just going to be, that's your magnitude. And to figure out phase, you do theta is equal to inverse tan of your x, y over x. So in this case, negative 33 over negative 33, which will get you pi over 2 basically. And the total should be pi over 2. And that's basically it. You just do the simple calculation between r and theta to figure out from the rectangular to polar.
I think it's minus pi over 2.
Huh?
I think it's minus pi over 2.
Oh yeah, you're right, it is minus pi over 2. Oh no, because you have to add pi onto it. It's negative 3 over 2, but in the end you have to add pi to it. Because like over here, it's going to be this is minus 3 over 2, but you have to add pi because it's in the third quadrant. So it comes over here and becomes pi over 2. Because like you can't do it with it.
Like, since it's in this quadrant, right there,
Yeah.
in order to calculate the angle of it, if you got pi over 2, that would be saying it's like that.
Yeah. Because like, I'm going off of here, so it's basically saying, so I think I did, I don't even know, but basically you get a quadrant over here, this is going to be negative 5 over 4, because then they're quadrant, right? And then you have to square it. Yeah, that's why I forgot about the square.
Or what?
Square, because the equation said you have to square this. And then you have to figure out the A and the A shape, whatever. So basically what they did here was like they did 33 root 2. And there's E to negative J.
And then what was the clarification? Yes.
And then square, and that gets you 33
Yes, all right.
squared times 2. E to negative J over 2. But because it's in the third quadrant, you have to add pi to make it into the first or fourth quadrant, or subtract pi, basically. I don't know if that makes sense. I have to redo that one.
Okay, great. I'll try to do that
Alright, we have problem A, which says negative 33 minus j negative 33 squared is equal to x plus jy equals z. So this is a simple rectangular polar conversion problem. So the first step you have to do is basically convert your rectangular to polar. And to figure this out, you know that since they're both negative, it's going to be in the third quadrant usually. And so after this, you can figure out the magnitude, which will be r is equal to the square root of your x squared plus your y squared, which will get you 33 root 2 after using the simple unit circle and the manipulations. And then, so you get, and now the step is you have to convert it to polar. And then you square the function, which is up here. So you get 33 root 2 e to the j negative so 5 6 4 and then you square and this equals 33 root 2 e to the negative 35 squared, which gives you 30 squared times 2 square root e to negative j 3 over 2. Now, because this is a negative quadrant, I have negative 3 over 2. And if you want to get this to the first quadrant, because you want it between pi, negative 5, and pi, you have to add pi to it, which gives you pi over 2. And so this becomes your phase, and your amplitude is 33 squared times 2, which equals That's for this one. And you did it using the simple